This is the Sun, 1,391,000 kilometers across. It holds 99.86% of everything in the solar system. Every planet, every moon, every rock, a rounding error. But tonight, we're going to shrink it down to something you can hold, a basketball, 24 centimeters. That's our Sun now. And if the Sun is a basketball, everything else gets very small and very far away. Let's zoom out. 10 meters from the basketball, that's Mercury, a pinhead. 0.85 millimeters. You could lose it in carpet lint. This is the closest planet to the Sun, and it's already across the room. 19 meters out, Venus, a pea, almost the same size as Earth, which is next. 26 meters. This is where you live. Earth, 2.2 millimeters. A single pea, 26 meters from a basketball. You would not be able to see it from the Sun. This is home. And the Moon, a grain of sand. 6.7 centimeters from the pea. That's the distance the Apollo astronauts crossed. 6.7 centimeters in a model where the Sun is a basketball. We treated it like an odyssey. The universe didn't notice. 40 meters out, Mars, a peppercorn. And now something happens. Nothing. For a very long time. Between Mars and Jupiter, there's a gap. In our model, it's almost 100 meters of empty space. No planets, no moons worth mentioning. Just darkness. The solar system is mostly this. Silence between objects, 136 meters from the basketball, Jupiter. And finally, something bigger than a dot, a golf ball, 2.5 centimeters. The king of the planets, and it would fit in your hand. Jupiter contains 1,032.11 Earths. 1,032.11 peas inside a golf ball. That's the scale we're operating at. A space inside a golf ball. That's the scale we're operating at. 250 meters. Saturn, a grape. With rings that stretch it to 5 centimeters, it's beautiful and it's 2.5 blocks away from the basketball. 500 meters, Uranus, a cherry. We're already outside the building, outside the block, walking down the street. The basketball is long gone behind us. 784 meters, Neptune, another cherry. Almost a kilometer from where we started. And the temperature here, in real space, is minus 214 degrees. In our model, it's just a long walk. 1 kilometer out, Pluto, just a tiny grain of sand. Smaller than a pinhead. At this scale, from our basketball Sun, you're searching for something less than a millimeter across. This is where Voyager 1 was launched toward. Sort of. Voyager 1, the farthest human-made object in existence. Traveling for over 4 decades. In our model, it has covered 4.2 kilometers. A short jog. The edge of a small town. And the nearest star? 7,000 kilometers away. Proxima Centauri, another basketball, sitting 7,000 kilometers from ours. That's New York to Lisbon, 2 basketballs separated by the Atlantic Ocean. And these are neighbors, the closest 2 stars to each other in our part of the galaxy. And here is where the model breaks your brain. The speed of light, the fastest anything can move in this universe, in our model it moves at 5.2 centimeters per second. Slower than you walk. Slower than an ant. The fastest thing in existence would take 4.25 years to crawl from one basketball to the other. You could outwalk a beam of light. So how big is the galaxy? The Milky Way in our model would be 165 million kilometers across. That's roughly the real distance from Earth to the Sun. The galaxy, scaled down to a basketball solar system, is still the size of Earth's actual orbit. There is no scale at which space becomes small. And here is the quietest fact of all. All 8 planets, Mercury through Neptune, if you line them up side by side, 7 centimeters. They fit in the palm of your hand. Every world, every atmosphere, every ocean, every hurricane, every city, every person. 7 centimeters. The solar system is 99.9999% nothing. Empty, silent, dark. And somewhere in all that nothing, 26 meters from a basketball, a 2 millimeter pea, spinning. That's you. That's everyone who has ever lived, and the universe didn't even notice.